Hello everyone! Welcome to my channel, where we explore the amazing mysteries of the universe. Today, we are going to talk about a very strange and fascinating planet that has been discovered by the James Webb Space Telescope. This planet is so fluffy that it has the same density as cotton candy, and it rains sand from its silicate clouds. Sounds unbelievable, right? Well, stick around, and I'll tell you all about this incredible world and how it challenges our understanding of planetary formation and evolution. The planet we are talking about is called WASP-107b, and it is located about 200 light-years away from us, in the constellation of Virgo. It was first detected in 2017 by the Wide-Angle Search for Planets, or WASP, which is an array of robotic telescopes that scan the sky for the tiny dips in starlight caused by planets passing in front of their stars. This method is called the transit method, and it is one of the most common ways to find exoplanets or planets outside our solar system. But what makes WASP-107b so special is its extremely low density. This planet is about the same size as Jupiter, the largest planet in our solar system, but it has only 12% of Jupiter's mass. That means it is much lighter than it should be for its size, and it has a very thin and fluffy atmosphere. In fact, it is one of the lowest density planets ever found, and it belongs to a rare class of planets called super-puffs, or cotton candy planets. How can a planet be so fluffy? Well, one possible explanation is that WASP-107b formed very far away from its star, where it could accumulate a lot of gas and ice from the protoplanetary disk, the cloud of dust and debris that surrounds a young star. Then, it migrated inward over time due to gravitational interactions with other planets or the disk itself. As it moved closer to its star, it got hotter and hotter, and its atmosphere expanded and puffed up, like a balloon. But it didn't lose much of its atmosphere because its star is relatively cool and faint and doesn't emit enough radiation to strip it away. Another possible explanation is that WASP-107b is a very young planet, and it hasn't had enough time to contract and cool down. Planets are born hot because of the energy released by their formation and accretion. As they age, they gradually lose heat and shrink in size, becoming denser and more compact. But WASP-107b could be only a few million years old, which is very young for a planet, and it could still be in the process of cooling down and settling into its final state. But these are not the only mysteries that WASP-107b holds. Recently, a team of astronomers used the James Webb Space Telescope, or JWST, to study its atmosphere in more detail, and they found some surprising and intriguing features. JWST is the most powerful and advanced space telescope ever built, and it was launched in 2021 after years of delays and challenges. It is designed to observe the universe in the infrared range of light, which allows it to see through dust and gas and to reveal the secrets of the most distant and dim objects, such as the first galaxies and stars. One of the instruments on board JWST is the Mid-Infrared Instrument, or MIRI, which can measure the spectra of exoplanet atmospheres and reveal their chemical composition and temperature. Using MIRI, the astronomers were able to peer deeper into WASP-107b's atmosphere than ever before, and they detected the presence of water vapor, sulfur dioxide, and silicate clouds. They also found no trace of methane, which was unexpected. Water vapor is not very surprising, as it is a common molecule in the universe, and it has been detected in many exoplanet atmospheres before. But sulfur dioxide is very rare, and it is usually associated with volcanic activity, as it is on Earth. However, WASP-107b is unlikely to have any volcanoes, because it is too large and too hot to have a solid surface. So, where does the sulfur dioxide come from? The answer is that it comes from the star. WASP-107b's star is a type of star called a K-dwarf, which is smaller and cooler than our Sun, but it still emits some high-energy photons, or particles of light. These photons can penetrate deep into WASP-107b's fluffy atmosphere and trigger a chemical reaction that converts water and carbon monoxide into sulfur dioxide and hydrogen. This process is very unusual, and it only happens because of WASP-107b's low density and proximity to its star. But the most bizarre feature of WASP-107b's atmosphere is the presence of clouds made of sand. Yes, you heard that right, sand. These clouds are composed of tiny silicate particles, which are the main ingredient of sand, and they form at high altitudes, where the temperature is around 500 degrees Celsius. That's hot enough to melt sand into glass, but not hot enough to vaporize it completely. So, the silicate particles remain solid, and they clump together to form clouds, just like water droplets do on Earth. But what happens when these clouds rain down? Well, unlike on Earth, where rain is liquid water that falls to the ground, on WASP-107b, rain is solid sand that falls and evaporates in the lower atmosphere due to high temperature and pressure of this zone, before rising up again and forming new clouds. This creates a cycle of sand precipitation similar to the water cycle on Earth, but much more extreme and exotic. So, WASP-107b is a planet that is so fluffy that it has the same density as cotton candy, and it rains sand from its silicate clouds. How amazing is that? This planet is a prime example of how diverse and surprising exoplanets can be, and how they challenge our theories and expectations of planetary formation and evolution. By studying WASP-107b and other exoplanets like it, we can learn more about how planets are born, how they change over time, and how they compare to our own solar system. I hope you enjoyed this video and learned something new and exciting about this incredible world. If you did, please give it a thumbs up and subscribe to my channel for more videos like this. Thanks for watching.